Okay. All right. I've just been looking on the Moodle questions, but hi everybody. So this is the Q&A session. Some of you did the numerics introduction to numerics course with me last semester anyway, so they know how I want to or how I run this. So I'm basically, you can ask questions on the videos or any parts of the course, lectures, whatever you want to ask questions on, and I will try to answer them. And I will also address any questions posted in the discussion forum on the Moodle webpage. So, how's it going with the course? Feel free to also hold on, I'm just going to open it. Feel free to also please switch on your video so that I can see a few people. I think it should be allowed now to open webcams as well if you want. And do fire away with any questions you might have on the course. So I have my notes from the videos here. If you want to ask anything, I can go over them. You can also type in the chat, of course. Okay, I'll start with the first question on the on Moodle. So that's the transformation from 1.8 to 1.9. Oops, wrong one. Should be here. Okay, yeah. So the difference between whether you have this 1.8 version or the 1.9 version is, as one of the other students already replied, is in the way you define U0 and U1. So in the first setting, we're using exactly the notation as in the general case above. We choose U0 to be U and U1 to be U primed. Then essentially U0 prime minus U1 is 0. That would be the first equation. And if I take U double prime, that's the same as taking U prime, and I get U prime plus omega squared U0. U1 prime, sorry, plus omega squared U0 is Ft. So that's for this setting. And for the other setting, we're going to choose, let's see, we want this to be I'm going to have a go. I need to check afterwards whether it's correct. Let's see if this is correct. Can you read my handwriting here? Sorry. Okay, let's see if this is correct. If I take U0 primed, that's U primed, is equal to omega times U1. Okay, that's correct. And if I take U1 prime, then that's U double prime. So U1 prime times omega is, no, it's not the right way. Let's try this one. Okay, so again, my handwriting is terrible. Omega U and U prime. Let's see if this works. So u naught primed is omega u primed, which minus omega u1 is 0. And u1 primed is u double primed, and then, yeah, that's correct. All right, everybody see? So we're just substituting slightly differently, and then we get this more symmetric version of the reformulated ODE system. So as I said earlier or here, around here, is that the transformation is not unique. So there is, in fact, infinitely many ways I could transform the system. Okay, let's see the other question on the discussion forum, which I haven't had a look at yet. Typing error in problem 1.2. Okay, that's a question on the problem sheet. Okay, good. Anybody got any other questions on the course? Guess we've only just started. There's not much yet to do. It's just that then you can essentially treat them all in one unified way. If you have a higher order differential equation, it's not so clear often where you would put your boundary conditions or initial conditions, whether you put if it's well posed, if you put a condition on the derivative or the second derivative or the third derivative. Whereas if you phrase them as a system of first order differential equations, it's very clear what the condition has to be to make it unique. And yeah, but in some settings, and we will see that at the end of the course, it pays off not to transform. So in particular, second order elliptic boundary value problems, I mean, there is a methodology which actually was developed in Heidelberg, which is called the shooting method, which tries to solve such problems by shooting from the boundary values on left and right. But the majority of methodologies attack the second order equation directly rather than transforming it into a first order system. So it's not that you always do that. It's just that for the first part of this course, this is a very generic way of solving general ordinary differential equations. Okay, other questions? So here I've got the notes as well. So maybe while you're thinking about questions, I'll just give you a little primer for what I'm planning to do. So I'm using Guido Kanchat's notes, which I already edited and corrected a bit and changed a bit 2 years ago. But as I go along, this year I'm doing more edits and also changing certain things. And when I change them, I will color the changes in blue. I had them in red before, but that was too aggressive. So I'm just changing it to blue now because red suggests something is wrong. I just want to highlight which things have changed. And so I'm highlighting all the changes in blue unless I forget them. Or if they're just minor changes, I don't make them blue. So one thing I did want to point out is that the Peano existence theorem and the Peano extension theorem was a little bit not as well phrased in the old version, and so I've been trying to rephrase this, and so you might have noticed that there have been various versions of this part, and even since I recorded the video, I'm not going to record it again. But even since I recorded the video, I have made a little edit again. So the Peano existence theorem is pretty straightforward and is given here. The Peano continuation theorem is the one that I added a proof to and that I edited a little bit. So this is now what I'll keep as the final version. Maybe just to say it again in words. If I have a continuous right-hand side function f of tx for our ordinary differential equation, on an open set. So the difference to the old version, so this is what had been bugging me the whole time when I did my proofs. I think there's a typo in the Ranacher book, and that's why that has permeated through to Guido's notes and then to my old notes. So we want F to be continuous on an open set, subset of R cross RD. Then for every initial condition T naught U naught in this set, there exists an interval T minus to T plus such that the local solution from the previous theorem can be extended. So we had before, as I drew it, we had existence, local existence proved in theorem 1.2.3. Around T naught, we found that we can find a capital T, which might be very small, but you can basically guarantee existence on this interval here. And then the piano continuation theorem says that provided provided F is continuous on some open set, and the cylinder that we used for the previous theorem fits inside D, we can just continue. We can take the endpoint here and continue the solution beyond to another point. And then if this is still in D, we can continue again. And we can continue this eternally until we reach the boundary of this open set. And because it's an open set, we will just simply get smaller and smaller intervals and fit in here, yeah? To add to this. This is what this statement and theorem says, and this proof says. And because the function f is continuous and f is du by dt, we immediately get that u has to be continuously differentiable on the whole interval. And the last thing here just says that if the D in fact contains the whole real line, then it is possible that the interval I is also unbounded along the real line in time. The time is unbounded. So you basically can have existence on the whole real line, provided D allows that. Okay, so have another read of this. It's slightly changed to the one I wrote down in the lecture on the video. Okay, and I got to somewhere in the middle of this section now, and I will finish with recording the rest of chapter 1. So yeah, I ended here, I got to here, and I will finish with recording the rest of chapter 1 later this week. Who will be allowed to use a handwritten paper in the exam? You mean like a cheat sheet, like one sheet of with the formulae or something? I don't normally do that because there's two types of exams. There's the ones where you give all the complicated formulae and when they're needed, and there's the ones where you don't. The problem is the second type sounds like it's better, but it means I can't ask any easy questions because they could all be on your sheet. So I find it generally better to have a closed book exam, and I'm very clear usually about that. I don't expect people to learn complicated formulae by heart. So if there is a complicated formula, then I will usually either get you to derive it or state it and then say you have to derive it or something like that. You can also unmute yourself. Please, it would be a bit more interactive rather than just typing. It is very unsociable at the moment, this whole Corona teaching. So I quite enjoy interacting with students. Okay, yeah, can do. So the question is, can I use a different color than blue because it's a little bit similar to black? Okay, I'll do that. Okay, anybody else got a question for the moment? I guess we're just at the start. If not, then we can make it short and easy today. As I said, I will record the second lecture probably on Thursday morning, and then post it at the end of the week. Well, post it on Thursday. Okay, good. I will change the color from blue to magenta or something, or maroon, something else. Um, and if there's any more questions, please do just type them in the discussion forum, and I will, during the week, you can answer each other's questions, or I will have a look occasionally. All right. Okay. Cheers. Thanks. Bye.